Hello, this is the next video in a playlist that I'm calling Transformations of Random Variables. And here we're going to look at the transformation y equals sine of x squared. And we want to find the density for y, and where x is a uniform between 0 and 2 pi. Now we're going to do two examples. The first example, we're just going to look at y equals sine of x, and then the second example we'll do y equals the sine of x squared. X in both cases is uniform from 0 to 2 pi, so this is the density. In example 1, we're going to let y equal sine of x, and we want to find the density. So this is the graph. This is x, and the sine of x looks like this. It's well known, peaks at 1 and -1. And if we back solve for x here, we get x is equal to the arc sine of y. Now we need to take the derivative of this for the Jacobian of our transformation. So derivative of x with respect to y is this. And I'm going to pass you off to a video that I have called Derivatives of the Inverse Trigonometric Functions. And in here I explain very clearly how this derivative is derived. Okay, so we're going to pass it off in this video and point you to this video for that derivation. Now, when you do transformations, they pretty much have to be one-to-one type transformations. So this is not one-to-one. It's a function, of course, but it's not one-to-one because it passes through more than one point. So now we have to break it up into regions. We have to do it in a smart way. Now remember, ultimately we want the density of y. So we're going to plug in values between -1 and 1. Okay? And we want to find the probability. Let's look just specifically for a second between 0 and 1. So if we plug in, say, 0.5, and then this is going to outcome a probability, or for that value. But here, when we plug in 0.5, it touches this function twice. So we actually have to find this probability and add it to this probability. And so you have to find the region. So like if we plug in 1, it only touches the graph once. So that's something you consider by itself. This region, there's two spots, so we'll kind of keep that as its own region. At at 0, y equals 0, it only touches once, right? These are circles. They don't, because it doesn't include 0 and 2 pi. Between here, it touches it twice. At -1, it touches it once. So we have to think about it. And ultimately, you don't have to think about it, but when you're new to this, this is the way I recommend it, okay? There's other ways, and perhaps even better ways, but this is the way my mind works. And so that's what you're getting. So we consider the regions at y equal 1, because it only touches it once. And that's when x is pi over 2. The second region is between here, and we get those. So this is actually, we're going to have to break this region into this region, which is what this says, and then this region, which is this, right? Because they have to be one-to-one functions of each other. Now the next region is y equal 4, because it only touches once, and perhaps we can combine this with this region, but let's not. So between -1 and 0, it's going to touch it twice. So we have to break, and it's not one-to-one, so we have to break it into this region, and then this region, which is this, and then the last one is when y equals -1. It touches it once, and so it's this point. Now, one thing to note, though, sometimes each of these regions, it could be a different function. Over this region, it's this, and this is another function. So you have to think about them separately. In this case, it's the same function. It's the sine of x. So no matter what region we're thinking about, it's always going to be this. So f of y is f of x, but you plug in the arc sine of -y. It's this. And then you take it times the absolute value of the Jacobian. Which is this. So this is the density plugged in arcsine, but there's no parameter, there's no variable, so you just get this back. And then this piece is the Jacobian. Now, look at this. If we plug in -1 to this function, this is 0, and 0 raised to the -1/2 is undefined. Or if you plug in 1 or -1, this is undefined. So f of y is undefined at 1 and -1. But you can plug in 0, which is which is this region, right? It's that point. And of course it works for the others. So this is the density. So when y is 0, right, that goes to 0, so it's 1 is 1 over 2 pi. That's the functional value. And then at all the other regions, not including 1 and -1, it's this value, which is this. So this is the density for sine of x. And I'll show you a graph of what that looks like on the next page. So now let's look at y equals sine of x, quantity squared. We want to find the density of y. Well, this is the graph, right? So normally the sine of x does this, but then we're squaring it as we go. So then we get something that looks like this, right? Because when you square something, it's always 0 or more, so it's always non-negative. Now let's back solve for x. So we have to take the square root of both sides. That's how we get this. And then we take the arcsine, and we get x is equal to this. Now the derivative of this, we're going to borrow what we did in example 1. So the way you think about it is, maybe you think of this as its own little variable. Think of it as like z or something, some other besides y to the 1/2. Then we said the arcsine was 1 minus that variable squared raised to the -1/2. But then when you plug in that -1/2 and then you square it, you end up with just y right here. But we have to do the chain rule, so then we take the derivative of this, so it's 1/2 and then y to the -1/2. And then this half is here, and then this can come under, the radical, the -1/2 can be combined, so the y, and then that would be y squared. So this is the derivative of x with respect to y. Now you have to think about the regions the same way. Remember, this is an open circle, and this is an open circle, because we're not letting x be 0 or 2 pi. But look at the region, so that if we're at y equal 1, it's touched twice. At y equals 0, it's touched once. In between, it touches it 4 times. So we have to break it into regions. And I kind of think of like 7 different regions. So when y is 1, so x is this, y is 1, and x is this. So there's 2, 3, 4, 5, 6, and then when y is 0, it touches it here, which is 7. But since it's the same function, we're going to do the same trick, or not trick, but derivation over each. And then we'll add them together depending upon what region we're in. So f of y is equal to f of x, but plug in the arcsine of y to the 1/2 times the Jacobian. And so we get this. So now notice this though, if we plug in 0, this is undefined. 0 minus 0 raised to the -1/2, that's undefined. If we plug in 1, that's undefined. So the density is only defined between 0 and 1. And we have to add each region, so we're adding this function 4 times. So it's 4 times it, and the 4's cancel, leaving just this. So actually this is the density for y, where y is equal to x, or the sine of x, quantity squared. And this is it. That's the answer. So now to look at a graph of these, x is between, it's not even on here, between 0 and 2 pi. But y, when you graph this function, is this. When you graph y equals sine of x, then it's this. And then remember there's a hole there, and it dropped down to that. And then the sine of x squared was this, which is this function. It's only defined between 0 and -1. And this is approximate values of what it looks like. Well, that's all I have for today. Hopefully you enjoyed that. Hopefully, it made sense and helped you. So please like the video and subscribe so you don't miss the next one. Thanks. Bye.